Bismillahirrahmanirrahim. Exercise 3.4, question number 2, part 1, integral tan 4x dx. The previous knowledge which we must have to evaluate this integral is that we know that from basic trigonometry, tan square x equals to secant square x minus 1. Integral of secant square x dx equals to tan x plus c. Integral of dx equals to x plus c. D by dx of tan x equals to secant square x, and we must discuss this formula of integration, that if we have a function, its power is n and its derivative is multiplied with it, then the integral of this thing, integral of f of x to power n into f dash x dx equals to f of x to power n plus 1 divided by n plus 1 plus a constant of integration. We generally call it as the power formula of integration. Now let's start the solution. I have named the integral as I. Integral I equals to integral tan 4x into dx. We write this tan 4x as integral tan square x into tan square x dx. Now what I'm going to do, I'm going to keep one tan square x as it is, and I'm going to write this tan square x as secant square x minus 1 using this result. Now open up the bracket. As a result, we are going to get two integrals. One integral will have tan square x into secant square x and dx. The other integral will have tan square x into minus 1, that is minus tan square x into dx. So open up the bracket. We better do it in two steps. We bring this tan square inside the bracket and we get tan square x into secant square x minus tan square x, and we keep the dx outside. Now let's open it now. As a result, we get two integrals, integral tan square x secant square x dx. I better erase it. Okay. Dx minus integral tan square x dx. Now again use this formula. Tan square x equals to secant square x minus 1. And what do we get? We get this thing like tan square x into secant square x dx minus integral secant square x minus 1 and dx. Now open up this bracket. As a result, you will get two integrals, minus integral secant square x dx, and then minus becomes plus integral dx. So let's write these. The first integral is, and now I'm going to make just a little change in the shape of this expression. What is it? I'm going to write it as tan x square. The same thing, but I have written it in a different shape. Into secant square x dx minus integral. Opening the bracket, I get secant square x dx, and then minus and minus becomes plus and integral dx. Now what is the advantage of this shape? Now I can compare it easily with this one. You can see in place of f of x, I have tan x. In place of n, I have 2, and f dash, that is d by dx of tan x equals to secant square. So in place of f dash x, I have secant square x, an integral sign, a dx. So all the requirements of this are there. So what do we get? We are going to integrate this expression with the help of this formula. In place of f of x, I will write tan x. In place of n, I will write 2, and of course then 2 plus 1 will become 3. So let's perform this integration, and I get tan x to power 3 plus 1, 2 plus 1, that is 3, divided by 3. What about constant of integration? I'm going to perform all these integrations, and in the end, I'm going to use one constant of integration that will serve for all these three. And integral of secant square x is tan x minus 10x, and then integral of dx is x, and here comes one constant of integration for all these three integrals. Now I'm just going to write this once again in a proper shape. 1 by 3 tan cube x minus tan x plus x plus a constant of integration, and that is the answer.